Hello everyone. Today I have brought a question that has been asked in chemistry question paper for the board examination of class 12th. Here the question is define adsorption with example. And further question is elaborated as what is the role of adsorption in heterogeneous catalysis. What is the role of adsorption in heterogeneous catalysis? Here this question is having two OR part also. In the OR part it is considered to be called as define Brownian movement. Question is define Brownian movement. What is the cause of Brownian movement in colloidal particles? And how it is responsible for stability of colloidal sol. How it is responsible. So that is the question for us. So let us understand first the first part, that is your adsorption. So we find that when concentration of solute is different at surface than bulk. So if there is a difference in concentration of solute at the surface with reference of the bulk, so at the bulk we find that the solute concentration is different, and at surface we find that the concentration is different for the solute. It is called adsorption. It is called adsorption. Examples like oxygen, hydrogen, carbon monoxide, chlorine, ammonia, sulfur dioxide get adsorbed on the surface of charcoal. Now the question is, what is the role of adsorption in heterogeneous catalysis? So adsorption of reactants on solid surface of catalyst increases the rate of reaction, due to more probability of collisions and effective collisions. Now we can also define adsorption as what? Adsorption is the accumulation of molecular species at the surface rather than bulk of solid or liquid. So we can define in this way also that accumulation of molecular species at the surface rather than at the bulk of solid and liquid. Example, we come across that your gases which are getting adsorbed on the surface of your activated charcoal, these are what example for adsorption. And we come across about the role of adsorption in heterogeneous catalysis, that here the adsorption of reactant on solid surface of a catalyst basically increases the rate of reaction. It increases the rate of reaction due to more probability of collisions and effective collisions. Now let us talk about the second part of the question. The second part of the question is define Brownian movement. Define Brownian movement. We find it your zigzag motion. Your zigzag motion of colloidal particles. Your zigzag motion of colloidal particles, which happens due to collisions between particles of dispersion medium along, that is your among themselves, and with particles of dispersion medium. That is what we are calling as Brownian movement. Basically, Brownian movement leads to stability of colloidal solution. And what is the cause of Brownian movement? It is caused by unbalanced bombardment of particles by the molecules of dispersion medium. Now the question is, how it is responsible for stability of colloidal solution? So we find that your Brownian movement has steering effect. It has steering effect which does not permit colloidal particles to settle down, and thus it is responsible for stability of colloidal solution. So finally we come across about Brownian movement, that it is a zigzag motion of your colloidal particles. So whatever the colloidal particles motion is there, the zigzag motion is called Brownian movement, and it happens due to collision between the particles of dispersion medium among themselves and with the particles of dispersion mediums. And it is caused by unbalanced bombardment of particles by the molecules of dispersion medium, and it leads to the stability of colloidal solutions also, and it is having a steering effect which basically does not permit the colloidal particles to settle down, and thus responsible for stability of your colloidal solution. So this is what a question which has been asked about, where we have seen about adsorption. In adsorption we come across that it is an accumulation of molecular species at the surface rather than at the bulk of the solid or liquid. Or you can say that the concentration of solute is different at surface and it is then comparison with the concentration of solute at the bulk. That is what adsorption. So we find that these gases are getting adsorbed on the surface of charcoal. That is an example for adsorption, and basically it increases the rate of reaction also. Thank you.